Let's take out our answers to yesterday's questions. Let's see if we agree on the answers. Now, what did we have yesterday? Given and odd functions. Like we had even and odd functions, let's look at the questions. Let's have this taking its time again. Why? I don't know. Deciding.
Must be still asleep as well.
Yeah.
Maybe if that wakes up, they'll wake up.
Yeah. Oh, it's taking its time. It's taking too long. Come on. Right, there we go. We had those 4 questions. Determine if the given functions are even or odd. Now, what did you come up with? The answers should be based on the properties for an even function and the property for an odd function. We know for an even function f of negative x should be equal to what? F of x. Then, if this property is satisfied, we conclude we have an even function. Then, if f of negative x is equal to minus f of x, then we know we are dealing with an odd function. Easy to check. We look at the first one. What did you decide? Got odd for the first one. Question number 1. Did we all get odd? I don't know what the answer is. I don't know.
I got even.
We got even. Right. Let's have f of negative x. The rule says the input is raised to the power of 4. So we have our input is raised to the power of 4 and added to the square of the input. We square the input and we subtract 1 and we keep going and we keep going. And we end up with what statement right at the end there? We will have the first term, will it be positive or negative? The first term. Did you get negative? Did we all get negative?
So I got 1. No.
Yeah. What's the term?
It's positive 4x.
Positive 4x. Is it positive 4x? Did we all get a positive 4x? What did we get? When we have minus x to the power of 4, what do we mean? Let's go back. What do we mean by minus x to the power of 4? We mean
Multiplying -4 together 4 times. So it means
so this means minus x times minus x times minus x times times is this all?
no, should more.
Yeah, that is all. That is all.
This one tells us, what does the 4 tell us? 4 of them. Do we have 4 of them? Now, when we multiply this, do we get a positive or a negative? Positive x to what power? Is it to the power 1? To the power 4. We have 4 of them. 1, 2, 3, 4. So we will have, this is the same as x multiplied by x multiplied by x multiplied by x, because they are, we get positive. The first 2 will give us x squared. The next 2 will give us x squared. When we put all of them together, we get x to the power of 4. So this one will be x to the power of 4. Then the second one, the second term, what did you get? Did you get a plus or a minus?
Plus.
A plus x to the power of 2. And the minus one, do we ignore it? No, we should have it. And then we look at this one here and we compare it with f of x. Are they the same? This one here. And f of x, do they look the same? Can we say this is equal to f of x? Now, if f of negative x is equal to f of x, we conclude we have, right. Let's look at the second one. The second one, what was your answer? For gx equal to x cubed, even or odd?
Odd.
Odd. This one is odd. Again, we have g of negative x is equal to, we look at our rule says cube the input, and so we will say minus x to the power of 3, minus x to the power of 3, do we get positive or negative? Negative, because we are multiplying 3 negative numbers, minus x to the power of 3. We get negative x to the power of 3. Can we include brackets here? Yes. If we do it this way, x cubed in brackets, will this be correct? Does this one and this one have the same value?
Yes.
Yes, they have the same value. When we remove brackets here, we get back to this one here. So they have the same value. Now, we look at the term inside the brackets. Is it the same as gx? This term inside the brackets here, is it the same? Right. If it is the same, can we write gx for the thing which is inside the brackets, and then we have a minus? Can we do that? Yeah. Now, if g of negative x is equal to minus gx. What type of a function is it? Odd. Right, we move on to the next one. Part 3. Part 3, we have hx is equal to, right, someone asked it about the vertical lines yesterday, and we agreed that vertical lines mean what? Absolute value. These vertical lines, they mean absolute value. Right, someone will say absolute value is too complicated. What does absolute value mean? Can we have another term with the same meaning as absolute value? Yes, and that term starts with an M, and we said it is, starts with an M. Anyone doing physics? Right, tell us, physicists. You use that word pretty often. That the same meaning as absolute value, we call that magnitude. And another similar term is for magnitude. When we say magnitude, we mean size. Good. This means the size. We are interested in the size. We are not worried about whether we are going left or we are going right. We just want the size. What value does it have? Now, meaning if we have -4 with those vertical lines, we are not worried about the plus sign. We are saying, what is its size? Its size is 4. And when we have 4 with a plus sign, we know its size is also 4. So this is what we mean by the vertical lines. It is the magnitude of absolute value is the common term which is mostly used, and size is the similar term. Okay. So based on that, hx is it odd or is it even? What did you find yesterday? We had lots of time to look at this. Even. Right, let's check. Let's see if we agree. We again have the input is -x. And we say this is equal to, we look at the rule. The rule says take the absolute value and add 1. And the absolute value of -x is x. And this is the same as x plus 1. Now this x here, can we say is the same as the absolute value of x plus 1? Yes. Now looking at this and looking at that, we notice they are the same. So can we say this is equal to h of x? Yes. So we conclude it is even. Right, what about the last one? Okay, x equal to x cubed plus x squared. What did you come up with? Is it even or odd?
Odd.
We all got odd. Right, the property for odd is this one here. Is it satisfied? Let's check. We say, check what we get when our input is -x. If the input is -x, then we will say this is equal to -x to the power of 3 plus -x squared. Then we simplify The first term, when we remove the brackets, plus or minus? Minus. So we have minus x cubed. The second one, when we remove the brackets, plus or minus? Yeah, plus x squared. Is that right?
Yes.
Right. Now, we are where we need to compare this one and that one. Do they look the same? No? So it means we can't say this is equal to f of x or k of x this time. They are not the same. K of negative x is not the same as k of x. So this means the function is not even. Right. Now let's try the other one. We are looking for a minus there. Now, if we take out the minus sign outside the brackets, because we are looking for the function inside the brackets to compare with that. If we take the minus sign outside the brackets, what do we write here? Our first term, will it be positive or negative? Positive, so that when we move, we will get a negative. So we have x cubed there. The second term will be positive or negative? Negative, so that when we have our two negatives, we get the positive that we had originally. Right, now, then we focus on the expression inside the brackets. Is it the same as kx? Are they the same? Are you sure it's not the same? Why not? Because here we have a negative, there we have a positive. So we see clearly they are not the same. So what does this mean? It means this one here is not kx. We can't write minus kx there. So this is not equal to what we were looking for, minus f of x. This is not the same as minus kx. So what does that mean? Does that mean it is still odd? Is it odd? No. We have just seen that it's not the same. How can we say odd when this one and this one are different? Remember, for odd, we should have minus f of x. This one here must be f of x with a minus sign. This one here is f of x with a plus sign. This one is even. This one is odd. Now we have checked here and found that this is not equal to kx. So it is not even. And we have checked again and we have seen that it is not minus kx, which implies it is
Neither.
It is neither. It's not even, it's not odd. So don't quickly jump to the conclusion that if it is not even, then it's odd. No. This one is not even, it is not odd as well. Okay? Fine. Right, let's move on to the next one. The system is not behaving for us now. Right, at last. after how many attempts? Right, we have done even and odd. Periodic function. Again, those of us who do physics, they do lots of periodic functions. What is a periodic function? Periodic function. We can deduce from the name. It is a function which behaves in what way? Come again?
Periodic.
Yeah, what do we mean by that?
Different periods.
Oh, meaning what? Remember, you are explaining to a layman who has not done maths. He'll say, you're a mathematician, do you do this stuff in maths? You say, yes. And he says, what do we mean by a periodic function? It is a function, that's the first thing, which has what property?
Which repeats. It's recurring.
Good. Which repeats itself after some interval a function f of x, which is such that f of x is equal to f of x plus a. We have a function. F of x will be equal to f of x plus a, will be equal to f of x plus 2a, and so on and so on. We go on and on and on. It repeats itself. Such a function is called a periodic function. Do we have examples? Yes, we have many examples. The one that I can think of straight away is a trig function. If we have a trig function, it behaves like this, and it behaves like that. We see that this value, for example, we'll read it off there is the same value. So it's repeating itself after an interval. After this interval, we have the same value. After another interval, we have the same value and the same value. As x increases, as x decreases, the same thing happens. We will have the same value. If we are on the horizontal axis, we still have the same thing. It is repeating itself. It is a periodic function. This function here reminds us of which trig function? We have done this before.
Cos.
Not cos. Sine. Sine starts at 0 there because the sign of 0 is 0. And it goes up and down, up and down, up and down, and it's a periodic function. And the a, we call that the period. The magnitude of this interval here, that's the period, it's the same period, it's the same value a. Mine is not a good graph, but it's supposed to be a periodic function. Right, now, we have done this. Now, let's look at graphs. Suppose we are given a graph. How do we determine whether it is an even function or an odd function? Read those two statements and deduce whether the sine function, this is the graph of y equal to sine x, deduce whether it is even or odd. I'm looking for an eraser next door.
I think odd.
It's not even.
Let's just hope we get the 50-50 right.
I was reading an textbook the other day. Zero.
I think it's even though, because y minus x is like x axis. Y minus x is y axis. Oh no, that's
If you want to make this positive, 0.
It's symmetric.
Symmetric, yes. So odd function plus rotation. What's symmetric, bro? Symmetry. Oh yeah. Well, I'll same on the side, same on the side,
Yeah, so it's gone below.
and then rotation. Yeah, it's even.
That's what I read anyway. It's wrong 3 times yesterday. So.
That's right.
Oh no. Oh, I see 180. Burning. That's odd.
Rotated, but it's still.
Yeah, it's not. It looks the same, mate. It doesn't look like the same on the same. Really odd. This one is like this. Second one.
Right. Sine function, is it even
Odd.
or odd?
Odd.
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 We look at these two statements, see the one which is satisfied by the sine function. If it is symmetrical about the y-axis, we say it is even.
Even.
If it is 180-degree rotation about the origin, then we say it is
Odd.
odd. So we test those for a sine function. Is it symmetrical about the y-axis?
No.
We cut through the y-axis. Do we have the mirror reflection on either side? This one is reflected on this one and this one is reflected on the other one. Do we have that? No, that doesn't happen. And if we rotate this one through 180 degrees, doesn't matter whether we go anti-clockwise or we go clockwise, because we are going through 180 degrees. Will this part here be on this red part here?
No.
We rotate through 180 degrees about the origin, which is this one here, which is 0, 0. Will we get the same shape?
Yes.
Yes, we'll get exactly the same shape. This red one will be on this side, this blue one will be on the other side. So it means it satisfies which statement?
Symmetrical.
The second one. The graph of an odd function is rotation of 180 degrees about 0, 0. The second statement satisfies this graph. So we conclude that this function is odd. Easy? Yes, I think it is. To test those two properties when you are given a graph, symmetrical, for example, if we have, let's take a simple example, y equal to x squared, and we were drawing the graph of y equal to x squared, what shape does it have? Is it a straight line?
Yeah. No, it's exponential.
Yes, what do we call that shape in maths? A parabola. Does it pass through the origin?
Yes.
Yes, it passes through the origin. We will have this one here. This will be the graph of y equal to x squared. Now, is this graph symmetrical about the y-axis?
Yes.
Yes. How do we see that? We cut through there. and see if we can reflect this onto this one and this one onto the other one, and we get this the same shapes. This one and this one, if we reflect, we'll get the other one. And so we say which property is being satisfied is the first one. So the graph of an even function is symmetrical about the y-axis. You can use symmetry or you can use reflection, entirely up to you. Or you can use both to confirm. Symmetry about the y-axis, then you know it is even. This one here, even if we use algebra, like we have been saying, f of negative x equal to f of x, we will see that this is also satisfied. It will say even still. So whether we are using a graph or we are using algebra, we should come to the same conclusion. If not, then there's something wrong. Let's find out what it is, and then we try and fix it. Right, let's move on to the next one. Now, check those two functions there and decide whether they are even or odd. F of x and gx. Use any method. There's no graph there, so you can use algebra if you want. Or you can draw the graph because the coordinates are there already. We have a table of values there. Done? If I were you, I would use algebra there. It's faster. But if you want to draw a graph, that's fine. Then up to you. If we have f of x equal to 4 minus x squared, find out is it even or odd. And do the same for gx equal to x cubed minus 2x. Even or odd. Done? Taking too long. Let's see what we get here. If we were to draw the graph, we are given values. When x is 0, f of x is 4. So we have 0 there and 4 somewhere there. This is our 4. And when x is 1, f of x is 3. So you plot that point as well. And when x is minus 1, we will get 3. And when x is 2, we will get 0. When x is minus 2, we will get 0 again. I can almost see the graph. So we conclude, or from algebra, what did you find? Even. Right. The graphs will look like that for both of them. Right. Which one represents an even function, if any, and which one represents an odd, if any? Let's start with the thinner one. That thinner one there. Is it even or odd or neither? Even. The thinner one is even. And the thicker one, is it even or odd or neither? That one is odd. If we rotate it around the origin, we'll get the same shape, but those two parts will be swapped, but it will be the same shape. Okay? Right, let's move on to the next one. Now determine whether this function is even or odd.
Odd.
Neither.
Don't guess, please. Please don't guess. In maths, we don't guess. We don't guess. We should justify we are saying this because of this. Even or odd?
Odd.
Odd. Why? Because if we rotate this one about the origin, we'll get the same shape, but those two arms will be swapped. And how about this one?
Even.
Don't guess again, test the property. Someone's whispered something. What did you say? Can you come again? Even or odd? Why? Why even? It is symmetrical about the y-axis. This one is obvious. It's symmetrical about the y-axis, so it is even. How about this one? Are you sure? Yes, this one is odd. If we rotate it, we'll get the same shape. So it is odd. Okay? Right, let's move on to the next one. The next one is coming soon. What is it? The next one is a type of a function. We looked at even function, we looked at odd. We are now looking at a composite function. Right, what do we mean by a composite function? Anyone with any idea? Good. When we put two or more functions together, we end up with a composite function. But how do we put them together? Are we adding them? No, we are not adding them. We are saying start with one function. Let's say the first function is f. The output will be f of x. X into the function f, the output will be f of x. But we don't stop there. We move on to the next one. Let's say the next one is g with its own rules. This output becomes the input of the next one, so the output will be g of f of x. Notice our input is f of x, so here we should have g of f of x. Suppose we have the next one, and the next one is h, with its own rules as well. Then the output will be h of g of f of x. This one here is a composite function. And this one here is also a composite function. That's why someone says when we put two or more functions together, we end up with a composite function. We don't necessarily stop it at three functions. We can go on and on and on and on, and they will all be composite functions. But the minimum number will be when we are dealing with two. Otherwise, we could have more than two, and we say that is a composite function. Right, now, how do we write the notation? Remember, mathematicians are very particular about the symbols they use. When we talk of a composite function, what are the symbols used? Easy again. We say for a function, we say f of x. This stands for the image of x under the function. Now, for a composite function g of f of x, we write this as g small ring f x. If we see this notation here, then we know we are talking about a composite function. G small ring f of x means start with function f and then move on to g. If we have f small ring g x, this would mean start with function g and the output of function g will be the input for function f. In other words, this is g followed by f, this is f followed by g. Any questions on notation? Are these two equal to each other? Can we say g of f of x is the same as f of g of x? Why?
Because there's no small ring.
There's a small ring there, there's a small ring there. Can we say they are the same? Not necessarily, please don't assume they will be the same. In general, these two are not the same, as you will soon find out. In general, the composite function f followed by g is not the same as f followed by g followed by f. It is only in special cases where they are equal to each other. Right. Now, let's look at the next one. This one we have done. Let's look at this one. Work out if we are given f of x equal to gx. And we are given gx is equal to x plus 2. Let's find these two. F of g of x and g of f of x. Grab a piece of paper and find out. What will be the two composite functions? Do we have Hala today? And Caleb? And Chess? Chess? Okay. And Francine?
Yep.
And B, Chu? And Sis? Jacob? Kate? Imesh? Selina? Jared? Ananiah? Callum? Chrissy? Matu? Alex? Awan?
Just always fine.
Awa, thank you. No? Anta? Xavier. Logan. Nathan. Z. Yes.
Yeah.
Zijin. Kant. Carlos. Eris. Right, have I missed anyone? What's the name?
Olivia.
Come. We identified here. Oh, Olivia. Okay. That one is easy. Don't worry. Anyone else? Come. Which one? This. I said this. Hmm? Were you thinking about something else? Oh, close. Right, we have our answers. The first one, f of g of x. We say f, gx, we know the output is x plus 2. So that becomes our input for the function f. And then the rule for function f. What is the rule for function f? It is cube the input. Our input is this one, so we are saying x plus 2 in brackets cubed. X plus 2 in brackets cubed, what does that mean? This means x plus 2 multiplied by x plus 2 multiplied by x plus 2. Then you remove these brackets, keep on simplifying, and that will be your function. Any questions there? Right, let's look at the other one. The other one is g of f of x. We say g of f of x. What do? We start with function f, and we have the output becomes the input for g. The f is x cubed. This becomes our input for function g. What does g say? It says the input you add 2. So we are saying the input is, what's the input? Here, the input is, the input is this one here, the one which is inside the brackets. That's our input, that's our x. Instead of just an x, it is x cubed. That's our input. And what does the rule for g say? It says add 2 to the input. So we have x to the power of 3 plus 2, and we are done. Any questions? And you can notice this one and this one are not the same. That's an example of where they are not the same. Right, some work to do over the next. Let's copy these questions. Copy that question there. Go and answer that after class and simplify your answers. You can use your device, that's faster. Right, also copy the next lot. Copy that question there, go and answer it and see what you get. And we'll go back there. And the next one is this one. copy that one, go and answer it. I think that should be enough. Go and answer those questions. They are to do with composite functions.
Sounds like compost, right? How can you relate? Compost.
Right, otherwise we're done. We can go now.
Compost.
We'll see you again.
Next, yes, tomorrow to show you. Oh, Friday.
On Friday, okay. Okay, see you Friday. Yes.
Like a chain.
Are you going to the J?
Only this is the one. All the others are doing it. I need some more ones.
You had to
I'm gonna Oh, this is good now.
Yes. Because the graph is not defined with 0, we can't divide by
So I can
0.
use this
Yes.
by 1.8.
You can't.
My integration. I pass my differentiation.